so now we're moving on to solving inequalities. Let's first kind of go through and make sure we know some vocabulary. First is an expression, is any combinations of numbers, variables, and operations. So for example, like here's a number might be 3 getting multiplied by some variable k. Maybe there's an operation like plus, and I don't know, maybe another variable, something like that. So numbers, operations, variables, there's no equal sign and there's no inequality sign. An equation is a mathematical statement containing an equal sign. Can I actually see the word equal almost in the word equation? So maybe I still have numbers with variables, but now I'm going to be equal to something. So equations will have an equal sign. An inequality is a mathematical statement stating that one quantity is not equal to another. So it will have one of these symbols. We've been working with them. It will either have less than, greater than, less than or equal to, or greater than or equal to. Okay? So it might be something like 7 plus p, and then let's pick one of these symbols, and 8. I don't know, something like that. So expression, no equal sign, no inequality. Equations have an equal sign. Inequalities have one of the 4 inequality symbols. All right, so this is practice for you. Just all you have to do is tell which one's an expression, an equation, or inequality. I'll let you do that on your own. I'm going to move on. So the next section, determining if a given value is a solution. So our first example here, x minus 5 is less than 8. And they're telling us that x is 9. So I'm going to replace that x with a 9, copying down everything else. Now we're going to simplify. 9 minus 5 is 4. Bring down the rest. Now I have to read this again from left to right. Remember, less than's look like the letter L. 4 is less than 8. So you're asking yourself, is that true or false? Oh, yes it is. It's true. So 9 is a solution to that inequality. Next one, c divided by 3 is greater than or equal to 4 when c is 12. So again, I'm going to replace the c with the 12, copying down everything else. Simplify. 12 divided by 3 is 4. All right, let's read this. 4 is greater than or equal to 4. That is also true. It's not greater than it, but it's equal to it. And it does say you can be greater than or you could be equal to it. All right, example 3, 2k plus 1 is greater than 11 for k is 5. So replacing the k with a 5. Remember, that means multiplication. Bringing down everything else. 2 times 5 is 10, plus 1 more is 11. Now, is 11 greater than 11? This one's a no. Make sure you know the difference between example 2 and example 3, like why this one was a yes and this one was a no. This one's a yes because it had the equal to on it. This one's a no because it doesn't. So that's all you're doing. You're substituting and then telling us at the end if it's a solution or not, just writing yes or no. So there's 6 of those for you to practice on your own. I'm going to move on. Now we'll get into actually solving for unknown variables. So this is just like solving equations. We have to know the opposites. The opposite of addition is subtraction. Opposite of subtraction then is addition. The opposite of multiplication is division. And then the opposite of division is multiplication. So when we're doing these, whatever we see, we're actually doing its opposite to isolate the variable. All right, solve each one-step inequality, then graph its solution set on the number line. So, example 1, I see addition. I know the opposite is subtraction. So I'm going to write -5 on this side. And just like an equation, we write -5 on the other side. Well, 5 minus 5 is gone, because that just makes 0. I have x left. Bring down my less than symbol, and 9 minus 5 is 4. So that's my answer. And then we're just going to practice graphing again. 4 goes in the middle, 5, 6, 7, 3, 2, 1. There's no equal to on it, so we get an open circle. The arrow is pointing to the left, and those are numbers less than 4. All right, the next one, 7x. This is tricky because I don't really see an operation. I don't see a plus sign, a minus sign, a times symbol, or division. If you don't see one and they're up against each other, it's multiplication. So the opposite is division. And we usually show division almost like a fraction. So we're going to divide by 7, both sides. 7 divided by 7 is 1, and 1 times x, just x. Bring down my symbol, and 21 divided by 7 is 3. There's my answer. I'm going to graph it. 3 goes in the middle, 4, 5, 6, 2, 1, 0. It has the equal to on it, so the circle is going to be colored in. Pointing again to the left, numbers that are less than 3 are over here. All right, in this one, the variable happens to be on this side. That's okay. Opposite of division is multiplication, so I'm going to multiply by 3. Goodbye. Multiply by 3 over here. 10 times 3 is 30. Bring down the symbol, bring down the x. Now, that is my answer, which we can leave like that. However, when we go to graph, we like to switch them around. Otherwise, we may graph the wrong way. So 30 in the middle, 31, 32, 33, 29, 28, 27. No equal to on it, so just an open circle. And now the new arrow is pointing to the right. So we're going that way. All right, there's 3 of those for you to try on your own. I'm going to keep moving. All right, so we're going to solve again to continue solving, but then this time instead of graphing, we have a follow-up multiple choice question. So I see subtraction, the opposite is to add, so add 1, add 1. -1 plus 1 is 0, so that's gone, just x is left. 64 plus 1 is 65. All right, so this is saying x is less than 65. Which number is in the solution set? So you're asking yourself, which number is less than 65? Oh, well, that's 61. Example 2. Remember, I don't see any symbol, so that means it's multiplication. The opposite's to divide. So divide by 11, divide by 11. Bring down this stuff. 99 divided by 11 is 9. which number is not in the solution set? So let's go back to our inequality. X is greater than or it's equal to 9. So the other one that's not bigger than 9 and not equal to 9 is the 7. There's a couple of those for you to try. Last section is writing an inequality from words, which is what we practiced last time, and then solving it. So example 1, a local restaurant will deliver food to your house if the order is at least $25. So we have to remember what that means. At least, remember, that's the lowest it can be. So I want things bigger than 25, or it could be equal to for at least. That's going to be the second part of my inequality. You are ordering pizza and wings for a total of $17.95. Write and solve an inequality to determine the minimum amount you still need to spend for the restaurant to deliver. So obviously that's not enough. We need to spend more. So $17.95. If I need to spend more, I'm going to have to add some unknown amount. So I wrote my inequality. Now we're going to solve. I see plus, opposite is to subtract. Both sides. Those are gone. All right, and then 25 minus 17.95 gives us 705. All right, so that's my solution set, but they want the minimum amount. So I need to spend greater than or equal to 705. So the minimum I need to spend is $7.05. I could spend more than that and they'd still deliver, but that's the minimum. All right, example 2. Darlene wants to keep her long-distance phone bill to under $40. If I want to be under 40, I have to be less than it. It costs her $2 each minute. What is the maximum number of minutes she can spend on the phone? So $2 a minute, I'd have to multiply the $2 times the number of minutes that I'm on the phone. So let's use 2m. There's my inequality. Let's solve. That means multiplication, so we're going to divide. And m is less than 20. Now, I want to know the most she can spend on the phone. She needs to be less than 20. Notice it doesn't have an equal to on it, so she can't equal 20. What's the highest number close to 20? 19. So if it has the equal to on it, you'll actually grab the answer. If it doesn't, you may have to go one lower or one higher. All right, there are also 2 of those for you to try on your own, and you can check your answers after.